Okay, before we start, I need to give some backstory. Once upon a time, there was this guy called Northwest AV Guy. He was pretty cool. He loved music and electronics, but he had a problem. He was sick of how expensive headphone amps were and knew he could do better. So he went to work creating an amp with all the features he could think of. It would be powerful, it would be portable, it would sound great, and it would be cheap. What he came up with was this, the Objective 2, or O2 for short. A weird combination of a portable and desktop headphone amp. People liked it. It was cheap, it was portable, it was powerful, and all the plans are available online for free. But some people had some issues. They thought the portability was holding the amp back. They wanted a full balls-to-the-wall desktop amp, none of this battery nonsense, and Northwest AV Guy agreed. So he started work on a proper desktop amp that would still be cheap and even more powerful. But there was another problem. The big headphone amp makers didn't like Northwest AV Guy. They said, "How can we let this guy cut into our profits? He designs these great amps and then releases the plans completely free. He must be stopped." So they concocted a plan to silence Northwest AV Guy once and for all. And one day, when Northwest AV Guy was in the middle of designing his awesome desktop amp, he heard a knock at the door. He went to go answer it, and as soon as he opened the door, poof! He disappeared and was never heard from again. So although we never got to see the amazing desktop amp, the Objective 2 is still a fully capable alternative that can be assembled for as cheap as $30. And that is what we will be building today. First and foremost, I highly recommend you read through the post on Northwest AV Guy's website. It has all the information you need to build an O2, and I will be referencing it quite a bit throughout this video. The first thing you're going to need are some tools. You'll need a soldering iron, preferably one designed for electronics work. I'll be using a Heiko 888D, a roll of rosin coarse solder, some flush cutters, a pair of needle nose pliers or tweezers for holding parts, a multimeter, and some wire strippers if you plan on doing some of the modifications I show in this video. Next, you'll need some parts. The whole parts spreadsheet can be found on Northwest AV Guy's website. All the parts are pretty generic and can be bought from any electronics supplier, but Mouser is probably the easiest because all the Mouser part numbers are included in the spreadsheet. If you have any questions on which parts are necessary and which aren't, read through Northwest AV Guy's website. If you build the amp exactly the same way I did in this video, you will need a 1/4-inch jack, which can be found lower down in the spreadsheet, this potentiometer knob, a panel mount 3mm jack, and a compatible panel mount power jack. Also, if you don't plan on running this thing on batteries, you don't have to bother getting the battery terminals. You will also need the PCB, which can be bought from any of these stores, and the power adapter. This is pretty hard to find because it's a 15-volt AC adapter instead of a 15-volt DC adapter, which are way more common. The easiest place to find it is probably the same place you order the PCB from. When your parts arrive, you'll be greeted with this big pile of tiny little bags. I recommend going through them and sorting them into piles, like one pile for resistors, one for capacitors, one for ICs, etc. Once you have them a bit more organized, go through them and write on the bag where the part should go with the reference code. For example, these diodes go in spot D1, D2, D5, and D6. This will make assembly pretty painless. Also, before you get started, print off a copy of the parts list so you can mark off which parts you installed as you go. Okay, now it's time to actually get building. Start with the smallest parts like the resistors and work your way up. I started with all the resistors, then the smaller ceramic capacitors and diodes. The stripe on the diodes should line up with the stripe on the PCB. Then the gain resistors, plastic case capacitors, and the IC sockets. Then I did the electrolytic capacitors, MOSFETs, and voltage regulators. The electrolytic capacitors have their negative side marked, and the polarization is marked on the board. The MOSFETs and regulators should be installed with their back facing the thicker line printed on the PCB. Take care in installing the MOSFETs. These are more sensitive than the other components to electric shock, so to be safe I recommend wearing a grounding strap while handling them and have all the resistors installed before installing them, as this will help protect them. Then I attached the front buttons and the volume potentiometer. And finally, I installed the power and audio jacks. I installed all these off the board on wires because I wanted the power and input jack mounted on the back, and there just isn't enough room on the board for the 1/4-inch jack. For the input and output jacks, you solder the wires into P1 and P2 respectively. These are their pinouts. And for the power jack, just solder the wires into the same hole you would solder the connector in. If you want to install any of the jacks off the board, make sure to buy panel mount jacks that come with a nut to screw them to a panel with. Otherwise, you'll have to glue the connectors onto the panel like I had to do later on. Once you have it all assembled, carefully look over the board and make sure you didn't miss anything, you don't have any solder bridges, and you didn't install anything backwards. Once you are sure, then we can move on and do some testing. The whole testing procedure is documented on Northwest AV Guy's website, and I recommend you follow that. I'll just summarize it here. The first test is testing the resistors. Make sure all the ICs are uninstalled except for U2, and then test all the resistors on the board, and the value should match with what is shown here. If the reading is off, switch around the probes, and if it's still off, you probably have a bad resistor that should be replaced. The readings don't have to be exact, but should be within the right ballpark. Next, measure the AC power pack. Remember to put your meter on AC voltage and not DC. Anything within 13.5 and 22.5 volts will work. If that's all good, remove all the ICs, plug it in, and check the voltage between these two battery terminals. This is the first time you'll be powering on the amp, so be careful. Just quickly plug it in, check the reading is good, and then unplug it. A good reading should be between 23 and 24 volts. If that's all good, install only U2 again, and check the power rail voltages, which are these pins on U4, and use the negative battery terminal closest to the gain switch as your ground. These should measure 11.8 and negative 11.8 volts. Next, install all the ICs and go through and check all these voltages, still using the battery terminal as your ground. Finally, test the output voltages. Both the left and right should measure less than 8 millivolts. If all these tests pass, then plug in a cheap pair of headphones and hope that nothing explodes. And if everything sounds good, you now have a fully functioning DIY headphone amp. Now all I have left to do is put it in a case. You can check out the video of me building the case here. The first thing I did was install the front plate and then install the PCB. And put on the nut for the 1/4-inch jack and the knob on the potentiometer. I then put a few layers of foam tape on the back to prevent the PCB from moving back and forth. Then I realized I hadn't glued the jacks onto the back plate yet, so I had to take it all apart and glue the power and input connectors onto the back plate. If you bought panel mount variants of these connectors, you could avoid this step and end up with a cleaner looking final product. After the glue dried, I put the PCB back into the case, installed the knob on the potentiometer, and attempted to put the nut back on the 1/4-inch jack, and failed multiple times. This stupid connector is really fiddly. But I did eventually manage to get it to cooperate, and the next thing to do was screw on the back plate. Then the final step was to install some rubber feet on the bottom, and voila, it is done. All there is left to do is plug it in, sit back, and listen to some music. This was a pretty fun project, and although I wouldn't recommend it to beginners, it wasn't all that hard to do. It sounds great, and if you live in the US, it can be built for 1/3 the price of the next competing amplifier. It can also be easily upgrade with an ODAC for an even better listening experience. If you're in the market for a headphone amplifier, or you just want a fun project to spend some time on, I would definitely recommend you try to build your own Objective 2.